Welcome, everyone. We're so excited for you to join us today. Dr. Danielle Stevenson has a lot of experience working in brownfields and residential projects in Los Angeles. And so she's here to discuss how ecological remediation strategies may help support fire recovery and particularly our post-fire soil contamination challenges.
Okay, thanks everyone for coming. My training is in environmental toxicology, and I've been doing bioremediation for over a decade. Please forgive me. I'm trying to share a lot of information tonight. I hope to be clear, but I fear I have a lot of detail in this presentation. So I'm grateful to Nicole for helping moderate questions. And yeah, we'll make sure to share lots of resources you can follow up and read more about later. And yeah, make lots of time for questions. So yeah, I'm going to be focusing on soil recovery and bioremediation, but I'm also going to be talking through other remediation options for soil. And we'll go through the pros and cons for each and some decision trees to help you understand and make a decision about which option is going to be right for you and your site. You are probably here because you know that soil contamination can cause harm for ourselves and our loved ones, and that young children and pregnant folks can be harmed most by exposures to contaminants, whether from soil or other sources. So I wanted to just ground in some immediate steps you can take right now to protect yourself while you're establishing a remediation plan and figuring out which remediation option is right for you. And this is especially the case if you're living on your fire impacted site. So, washing your hands regularly, removing your shoes when you enter the home. Doormats are an amazing way to keep some of that lead and those other contaminants in the soil outside rather than tracking them inside. For contaminants that do make their way inside, you can wet mop your floors and wipe your surfaces. Use HEPA vacuums and air purifiers. There's also free blood lead testing available through LA County. And if you can, just cover the soil with some type of free or cheap material that'll help keep some of that dust down and prevent it from blowing around into your home or your neighbor's home. So remediation just means cleaning up pollution in the environment. And it's typically done one of several ways, through removing the pollution, treating it, or containing it. And so those three kind of categories are how we're going to be framing this presentation tonight, right? So, for example, removing pollution as a remediation method, that's the most common one that, could look like digging up the soil and dig and dump or excavation. Treatment can look all kinds of ways, but we're going to be focusing on more nature-based treatments known as bioremediation tonight. And then there's always containment, and that has different names: capping, covering the soil, stabilizing the contaminants. So we'll talk through all of those. What is being found in the soil so far? I would recommend actually watching a webinar from about a month ago where CAP LA and Clean shared their most recent results. I don't have access to all of those, but I'm just sharing what's been found so far that's reported through LA County and through the Clean program. This data is from the Clean program specifically, and generally, findings for their lead testing program are that the levels are higher in the Eaton fire area as compared to the Palisades, which you can see in this figure here showing average lead concentrations. So roughly, I think 3 out of 10 homes in the Eaton Fire area have elevated metals, compared with 1 out of 10 in the Palisades. And unfortunately, little testing for other types of contaminants beyond lead and metals has been carried out. This is probably overwhelming. I created this. It's also available on a soil testing guideline on CAER's website if you want to refer to it. This is just showing common post-fire contaminants, where they come from, what they're called in case you do send some samples to an outside lab and you need to know the right terminology, and basically what you can do with them in terms of remediation. So, for example, metals don't biodegrade, they persist. So if you're remediating them, you're basically moving them around or stabilizing them in soil. And I guess the main thing to point out here is that, again, really only that first class of contaminants, metals, and in some cases only lead, have really been tested in most cases after the fires, even though we know that fires create kind of a slew of everything that was in our homes and vehicles ends up in the soil, the air, the water. I'll also just point out, there are some contaminants, as we'll get more into, that technically are degradable. They technically could degrade, but they don't in practice because they're so persistent and so complex. So PFAS is a class of contaminants that would be described that way. So they're pretty much probably going to still be there if you test it in 50 years, unless they washed away or something. This is a slide from my just typical presentations on understanding soil contamination. I put it in here because, we know that remediation and rebuilding efforts are not happening at the same time everywhere. They're happening, your neighbor might be doing some rebuilding or some soil excavation. And those uneven building efforts and different efforts in neighborhoods can mean that there's dust that kind of can move around between sites. Contaminants can also be deposited on sites through water, whether that's rain or runoff. And we did have a lot of rain, in the last months. So yeah, these are things to keep in mind in terms of your remediation strategy. Are you going to need to be doing ongoing monitoring to some extent, or how might you want to time that or mitigate for the possibility of, even small amounts of contaminated dust or water ending up on your site? So yeah, I always like to really start talking about remediation by discussing the different, just broad categories of contaminants. And that's because they can be remediated, or they need to be remediated in different ways. As I already mentioned a little bit when I said metals don't biodegrade, right? So you just move them around. So the two main categories are organic contaminants. These are carbon-based. That means they were made or derived from something that was once alive. And the cool thing about that is that means there's probably a fungus or bacteria or something that would eat it or break it down to get food. So organic contaminants, although they vary in their complexity and how easy it will be for them to be degraded by a fungus or something, they generally can be transformed or broken down or biodegraded. That's not the case for inorganic contaminants, which are elemental, also known as metals or heavy metals. So examples would be lead, arsenic, hexavalent chromium, and so on. Whereas examples of organic contaminants would be, diesel, agrochemicals, even technically plastics could be considered organic contaminants. So yeah, most metals can't be transformed into less toxic forms. They certainly can't be biodegraded. So that means they stick around. So they stick around in soil, they persist, whether the lead was deposited in the 70s from when we still had leaded gasoline, or it was deposited from, a more recent event. It's going to stay there unless it washed away or you remediate it and remove it from the soil or remove the soil itself. Yeah, most of the time, contaminated soils have a mixture. And that's because, like even with that example of leaded gasoline, right? That's an example of a mixture of contaminants just from one source. So typically, we end up with lead in the soil, maybe from leaded paint that was used in old homes, from leaded gasoline days. And then we have PAHs could be from fires, could be from, burning gasoline, exhaust. So typically we end up with these mixtures, and that makes it really important to consider which remediation strategy will work for you. This is part of why just removing the soil is kind of considered the gold standard, because you just get rid of the soil that has all these possible contaminants. I wanted to do a little toxicology interlude because I think it'll also really help folks understand their risk from soil contamination. I know it can be really scary to get soil test results back with, a lead level higher than the screening limit. And it can be difficult to understand, how much of a risk to you there is from those soil test results or those contaminants that have been found. So I just want to take a sec to talk through that and help make sense of that. This will also become relevant when we're talking about how different remediation strategies work. So I love these cartoons from class. They're just showing that, a hazard is something that has the potential to harm you. So here we have two examples. We have a shark as a hazard, and we have the sun as a hazard. Risk is the likelihood of a hazard causing harm. And how do you understand your risk? You basically have to have exposure to that hazard to be at risk of it harming you. So the equation here is that the risk is your hazard times your exposure. So, right, if you are standing on a beach, there can be a shark in the water, and there's essentially no risk to you of that shark hurting you. If you are on that same beach, but you're under a sun umbrella and you're covered up and you're wearing sunscreen, there's really no risk, or very, very low risk of the sun causing harm. And it's the same idea with soil contaminants, right? So there can be lead in your soil that's at a higher concentration than the residential screening limits. That means it's a hazard to you, right? But the risk to you depends on you being exposed to that lead. So if the lead is in soil that's underneath concrete, there's really low risk of you being exposed to it. It's trapped under the concrete. And that means it's a low risk to you, even though it's there. I'll just briefly touch on this. Some of you may be familiar, if you're, an environmental science or even maybe a gardener, you might be familiar with the concept of bioavailability. It's basically the amount of something, like a substance that can directly affect or be taken into plants or animals or humans. So, for example, if you're a gardener, you grow plants, you might know that there can be like phosphorus, there can be nutrients in the soil that your plants need, but they might not be available to your plants. They might be kind of like locked up for some reason or another. And the same is true for contaminants. They can be more or less bioavailability. And this really comes into play. It's nuanced, but it comes into play when we're, again, considering remediation strategies such as stabilization, right? Where we maybe want to not remove the lead or the other contaminants, but reduce their availability. So we reduce exposure to them. Since exposures are the way that a hazard in soil or soil contaminant can cause risk, I just wanted to go through some of the pathways that we can be exposed from contaminated soils. And I circled dust because in such a hot, dry place, that's a major way. I think like 50% or more of exposures from contaminated soils happen actually inside the house from dust that contains those contaminants that gets inside the house, again, tracked in through shoes, blown in, or whatnot, what have you. For some contaminants that are volatile, like if you think of when you're at the gas station, you can really smell that gasoline. That's kind of an example. We can sometimes be exposed through vapors that rise from the soil. Children and pets are in a lot more contact with soil and will actually get it in their mouths and ingest it. So ingesting soil is another exposure route. And then if we're growing crops, like so if you have a food garden in your contaminated soil, the contaminants can get in or on the crops and we ingest them accidentally that way. Understanding these different pathways brings us back to that first slide, right, where then we can mitigate them. We can prevent them from happening, right? We can stop tracking soil and dust into the home. We can filter the air. We can, things like that. We can reduce those potential exposures. How do we know if we need remediation? Through comparing your soil test results with residential soil screening limits. So soil testing is a big part of this equation. It's really the only way to know if your soil is contaminated. Then the soil screening limits can be really complex. I can share a link to a table with those guidelines. I will say that there's different levels of risk for vulnerable populations. So children under the age of 6, people with health concerns might want to choose a different level of risk, right? A different screening limit. So you might have, lead levels, for example, maybe they're at 80. They're at 80 parts per million, which is the California residential screening limit. But because there are young children on the site who are more likely to be exposed to the lead and way more at risk of being harmed from it, maybe you're going to shoot for remediation that gets that lead to nothing, right? Because really no level of lead is considered safe for children under 6. So this is where understanding risk and then how to mitigate it hopefully can help you make your own decisions about the level of risk you're comfortable with. And all of this will help you decide on which remediation strategy is right for you, right? Right. So building off of this concept of exposure, remediation strategies can then be kind of seen as whether they remove the contaminants altogether, either by removing the soil or removing contaminants from the soil, or by or they can focus on reducing exposures to contaminants, right? That can be done by covering or capping the soil, by diluting the contaminants with clean soil, or by stabilizing the contaminants in soil, reducing their bioavailability. This is just a summary diagram I made for a set of soil remediation guidelines that are coming out soon. So here we're looking at 3 kind of main remediation strategies. I already shared these at the beginning, right? In their relative costs, whether there's any maintenance involved, and the amount of time they take. That's based on what we hear a lot from people are really important factors in helping pick a remediation strategy. But there's other factors to consider as well, and we'll go through those too. So we have, right, dig and dump. It's highly expensive. Once it's complete, and there's been testing showing it is complete, there is no further maintenance, which is nice. And it is very fast if you can find a contractor, right? A capping or stabilization approach where you cover or stabilize soil contaminants can be quite cost-effective or cheap. However, you're going to need to maintain that possibly forever, and disclose it typically if you at some point sell your property. It can be done quite fast. So this is one of those approaches, right, that again, it's not removing the contaminants, it's just reducing those exposures or the risk of exposure if it is maintained, which I will get into how to maintain them if we have time, hopefully. And then finally, sustainable treatment. So many terms for this: nature-based remediation, bioremediation, ecological remediation. These are methods that clean the soil in place and actually treat or remove the contaminants if done properly. So this can be a lot more cost-effective than dig and dump. Similarly, there should be no maintenance once it's complete. However, it can take more time, right? Nature takes time, so it can be a slower approach. So when you're deciding which remediation strategy is right for you, there are a bunch of things to consider. One of them is potential challenges with disclosures when you're selling your property. May not be an issue for you, but it's something to, like, if you plan on not selling your property, for example. But other remediation options like capping or stabilization, potentially bioremediation, depending on how it's done, could create challenges with disclosures unless you especially if you choose an approach where you don't remove the contaminants and they're still there. Another thing to consider is if you're growing food on site or you plan to. So if you're going to be growing food, you want soil that is remediated to levels that are akin to agricultural screening limits rather than residential. Or you can decide to grow food in raised beds filled with clean soil rather than directly in the soil on site. Another thing to consider, as I've mentioned a few times, do you have or plan to have children and or pets who play in the soil? Are pregnant individuals living on site? If so, you may want to prioritize a high certainty remediation approach, like removing the soil or at least hotspots of contaminants, covering the soil, and combining all of that with all of those exposure reduction strategies, right, that we talked about initially. You want to consider your budget and whether insurance will cover any of your soil cleanup, right? The costs can vary really widely. So if you have limited funds or your insurance isn't going to cover it, you might want to consider, again, either a combined approach, just remove hotspots, and then maybe bioremediation would be a good option for you since it is a lot cheaper. You want to also consider the availability of services and materials. So I think I could imagine periods of time where there might be, like gaps in availability of even soil removal services, right? If thousands of people are needing them at the same time. So that's one example. You want to consider your timeline, right? These remediation approaches all take different amounts of time. So unless you consider maybe a combined approach like bioremediation on a portion of your site while rebuilding happens on the other, creating a permanent cover, it's important to consider how much time you have and which strategy will fit with your timeline. And then finally, just how much certainty do you prefer? So we're all very different in how much certainty we prefer, right? If you want the highest certainty, just removing the contaminated soil and replacing it should give you that, right? The lowest certainty is probably covering the soil or stabilizing the contaminants because there are different things that could re-release those contaminants or re-expose you potentially, depending on which method of covering the soil you work with. So again, you can kind of mitigate for the certainty factor by choosing a combined approach, using exposure reduction methods right away, removing hotspots, and then, maybe carrying out longer term soil improvements with bioremediation as time and resources allow. Okay. So I'm going to talk a little bit more about dig and dump briefly before focusing in on bioremediation. And then if there's time, talking about capping also. So we know, one of the downsides of dig and dump is that this contaminated soil gets dumped in other communities. It's actually a really big waste stream that California exports to other states, and this leads to greenhouse gas emissions that are significantly higher than other remediation approaches. So again, the cost is really high. Been hearing anywhere from like $40,000 to hundreds of thousands of dollars per site, depending how much soil is removed, how much soil is replaced, and how much grading and other work needs to happen. So I think we already covered a lot of those factors. So the question that's been driving me over the last decade or more is really like, what are other options here that actually can address the pollution and are more cost effective and environmentally sound? And that brought me to bioremediation, which works with living organisms to clean up environmental pollution. Some of the major advantages are that it can be done in place and reduces or removes the need for soil excavation. Often cited as being 50 to 90% cheaper than dig and dump, and repair soil on site in addition to other benefits. So there's a number of different bioremediation methods, more than I'm even showing here, but I'm going to cover these three main ones. So we have working with plants, which is called phytoremediation. Working with fungi is mycoremediation. And working with bacteria to clean up pollution is microbial remediation. A couple technical details that I hope will be helpful. There are many different types of each of these approaches. There's actually many more types of phytoremediation that I'm showing in this figure, but I wanted to call out two major ones. For metals, for dealing with those metals, which again do not biodegrade. So there are some plants known as hyperaccumulators, meaning they pull like huge concentrations of metals out of the soil relative to other plants. And some plants that are hyperaccumulators just then, hold on to those metals in their root systems. Those plants are helpful for phytostabilization, which is a stabilization approach for metal contamination in soil, right? So if you have perennial plants that live for long periods of time, trees, bushes, things like that, that will pull up the metals and hold them in their root systems, it's possible they will stabilize them and prevent them from blowing all around or getting into the water. That is reversible. I mean, there's a lot of things with any stabilization approach that could change that and re-release those metals. Something to think about. Another option is to work with hyperaccumulator plants that pull in metals and then send them above ground. It's a lot easier to then remove those metals from the soil when they're in the above ground parts of plants. So in this way, certain plants can actually act like, said before, I don't love comparing these amazing plants to vacuums, but they do sort of act like a vacuum, kind of sucking metals out of the soil so that we can then remove those plants. And the soil is being cleaned of those metals. That type of approach is called phytoextraction. Switching now into the fungal kingdom, for those who are unfamiliar, I just want to clarify some terminology. So when we're doing remediation with fungi, we're typically working with the living fungus itself, which is something known as mycelium. Something we don't usually see. We are sharing a picture of it here, living fungal mycelium. And this is a diagram showing what that can look like. That's the living, eating part of the fungus. Mushrooms are just the reproductive parts, kind of like the fruit, like an apple on an apple tree. Not all fungi produce mushrooms. But again, typically with remediation, we're working with fungal mycelium, the living part. And there's two groups of fungi that are especially important in remediation. And that's because one type can help us deal with organic contaminants, and the other can really help us deal with metals. And so the first group of fungi I want to talk about are the arbuscular mycorrhizal fungi, AMF for short. These are plant symbionts that live in relationships with most plants on Earth through their roots, and they trade with the plant, helping them grow. They have been found to enhance phytoremediation success, and I'll share more results from my own studies with these AM fungi. We also have fungi who are decomposers, meaning in nature, they break down dead stuff. They break down dead trees, dead plants. These decomposer fungi can also break down complex organic contaminants like PAHs, diesel, and even PFOS. And so what happens in nature, though, is that we don't see any individual kingdom of life or individual species on its own, right? We see all these different kingdoms and a diversity of species all working together, each of their lives creating food and habitat for other lives. And this is how soil really heals. This is also how we can actually address mixed contaminants in soils, right? By mimicking nature. So in our bioremediation strategies, we typically have beneficial decomposer fungi to treat and actually degrade and eat and break down and transform those organic contaminants. As they do that, they create healthy soil that now bacteria and other decomposers can continue to work on those simpler compounds. We work with hyperaccumulator plants that pull up metals out of the soil. You might be asking, why do plants pull metals out of the soil? I don't know that I can say for sure, but in nature, all plants pull up nutrient elements out of the soil, right? Like phosphorus, nitrogen. Nutrients are elements like metals. So it's possible that certain hyperaccumulator plants are just really good at pulling up elements out of the soil. Anyway, so we'll have these hyperaccumulator plants in the mix to treat those metals and remove them from the soil, send them above ground. And we want them to be supported by those arbuscular mycorrhizal fungi so that they can, again, which earn their living by trading elements with, and other stuff, but trading elements with their plant partner. So the hypothesis here is that AMF can help these plants survive in bad soils and maybe take up even more metals, right? And so this is a complete bioremediation system here, mimicking nature, designed to treat mixed contaminants. And so CAER's bioremediation approach is based on identifying regional native plants and fungi that can help remove metals and organic contaminants from the soil, and then testing those on contaminated sites from residential to brownfields across LA County to figure out the best combinations and do you need irrigation and all sorts of things like that. So first, I just want to briefly share that first study I mentioned where I visited 7 contaminated sites across LA and Orange County and identified all the life there that, nobody had planted or nobody had watered, were somehow thriving in contaminated conditions. So that publication is available open access if you want to read the whole thing. But basically, we identified through testing the plants that we found growing there, the top native metal accumulator plants in the region. This is a picture of one. This is telegraph weed. It's not a weed. It's a native plant that pulls up lead and other metals from the soil. Here it's growing out of literal asphalt on an old gas station. I'm not going to go through these fungal species we found in detail, but again, it's all in the paper if you want to check it out. I just want to point out that there were a lot of extremophile fungi, some of the same ones that have been found growing in Chernobyl and other really wild types of contaminated settings. So we found them growing in soils on contaminated sites in LA County. I do want to acknowledge that, based on this study, we did find that those arbuscular mycorrhizal fungi were found in really low amounts and low diversity on these contaminated sites, which tells us they're a bit more of a sensitive group of fungi. And given how important they are to remediation and to plant and soil health, we might want to consider re-inoculating with this kind of fungi. So then we tested the top combinations of native plants and fungi we found growing naturally on those contaminated sites in that first study on 3 brownfields in LA. Here I'm showing those brownfields. You can see they're different sizes and they had different combinations of lead and metals and organic contaminants. And we looked at and compared different types of treatments, right? We compared just stimulating the fungi that was already present by adding wood chips and irrigation. We compared like inoculating intentionally with those mycorrhizal fungi from a commercial source and with a native decomposer fungus. And then we looked at, these previously untested native plant metal extractors. We compared it with an already proven non-native metal extractor and all the different types of fungal inoculum. And so what did we find? First of all, that native plants are really under-recognized remediation tool, especially in Southern California, because they're already adapted to the conditions here, including fire and drought. And they have extensive root systems. So one of the major limitations of phytoremediation is that it's only as effective as the roots can reach those metals, right? So working with California native plants can really extend the capability for phytoremediation. What did we see with the soil metals? We saw that plants and fungi together reduced all soil metal concentration significantly in the 12-month period the study ran. And so here I'm showing reductions averaged across 555 plots across 3 brownfields covering 3 acres. So we saw reductions in lead, copper, zinc, nickel, cadmium, arsenic, and hexavalent chromium, which I'll speak more about. And it turned out that making sure those arbuscular mycorrhizal fungi were in the mix by adding them back in with a commercial inoculum was the most significant contributor to plant metal removal from soil and to the plants surviving and producing a lot of biomass. So this is a figure some of you may have seen before. It's the most exciting one I've seen from my research. And I'll just walk you through it. So on the vertical axis, we're seeing the bioconcentration factor for lead, which basically means how much lead did the plants take up. On the horizontal axis, we're seeing the level of AMF colonization. So we actually looked in the roots of all the plants. And so you can see there's basically no lead being taken into any of the plants in our study when there's no or low levels of these arbuscular mycorrhizal fungal relationships. After there's 50%, so significant amount of AMF root colonization, we suddenly get a lot of lead uptake. This was also the case for arsenic and chromium, but I wanted to call it out for lead because lead is thought to not be, well, first of all, lead is everywhere. There's a reason it's the most tested contaminant. It's really ubiquitous. It's found in a lot of soils all over. It's also a neurotoxin and very harmful for children and pregnant folks. And it's not thought to be treatable by phytoremediation. So it was exciting to see that when we mimic nature, when we have these beneficial plant support fungi in the mix, then lead is possible to remove from soils. And what happened with all those organic contaminants on these sites, which included PAHs and solvents and petrochemicals, we saw them pretty much transformed, disappeared, eaten, degraded by almost 100% in the 12-month period with our fungal treatments. So I just wanted to show you some pictures of what this looks like, some before and afters of these sites, just that to show that, when you mimic nature, not only remediation happens, but regeneration happens too. This is the former gas station site. This is the former chrome plating automotive shop site. and this is a former rail yard. So I think in the interest in time, I will move quickly through some of these next sections, so there's lots of time for questions. I just wanted to clarify that the only way to know if remediation is working is by testing, not just the soil, but also, if you're working with plants or other organisms, by testing those as well. And that one of the downsides to plant-based approaches, phytoremediation approaches, is that you end up with these byproducts, right? So you'll need to have a plan. If you're doing this yourself, you need to have a plan for what you'll do with any materials produced from the remediation efforts, so that they are tested and then potentially treated as a hazardous waste. So this isn't something you would put in your compost, let fall back on the soil, or send away to a normal, green bin or anything like that, right? The metals don't break down. So if you were successful, the metals ended up in the plants, you need to test for that and then dispose of those plants properly. And because I always get this question, I'll quickly mention the two main ways plants used in phytoremediation are typically exposed of. And I'll just quickly ask that everyone please mute yourself, getting some sound on this end. So the two main ways phytoremediation plants or mushrooms or whatever are processed after remediation is through incineration, controlled incineration. So you transform that biomass into ash in a controlled way that doesn't release those metals back into the air, or through sledging. So you basically anaerobically compost those byproducts down. Either way, instead of having to remove all of that contaminated soil, you remove the metals from the soil with these natural methods, and then you concentrate that biomass. So you end up with a lot smaller, concentrated amount of hazardous waste. In our own work, we are exploring making biofuel and mycomaterials and other more circular options for that those byproducts. We've also done some calculating the climate and biodiversity metrics for these approaches, specifically how much greenhouse gas emissions are avoided with this method instead of dumping that soil elsewhere, how much soil carbon gain, microbial biodiversity gain, and vegetation recovery as well. We've also tested metals that form on burn sites with some grade 8 students. It was a very cool project to look at whether certain mushrooms hyperaccumulate metals. As I expected, I have way too much material here. I'm going to briefly move through this case study on hexavalent chromium because it is especially relevant to post-fire contexts. And then we'll see what we have time for after that. This study looked at some similar treatments as I mentioned in my past studies. Just to clarify, chromium-3 is a form of chromium that some of us may take as a supplement. It's a micronutrient. It is not toxic at all, and it's not very mobile in soils. But when chromium-3 gets heated up, so industrial processes, fires, it can transform into a toxic mobile form of chromium called hexavalent chromium. I just have this picture because I've worked on sites with hexavalent chromium contamination, and it looks like neon, like this kind of neon yellow color. Okay, so I'm going to jump right into what we found with the same approach where we have mycorrhizal fungi, plant hyperaccumulator plants, and decomposer fungi. And so what did we find? Well, we found, unsurprisingly, because these fungi are my favorite, that AMF not only increased the plant growth, the phytoremediator plant growth, biomass and height, even when soils were drought and hexavalent chromium toxicity stressed, which is very clearly visible not only in our data, but qualitatively. Look at this. These are two plants in the same exact condition. They have high amounts of hexavalent chromium. They're droughted, but this one does not have AM fungi, and the other one does. So in addition to that, we found that AM fungal inoculation reduced the soil chromium concentration by 45% in an 8-week period. And so this is a little complex, but I'll walk you through it. So in fact, when there was AMF inoculation, hexavalent chromium was reduced by 45% on average. I just said that. So that's good. But it's even worse if you don't have those AMF. Without AMF, the hexavalent chromium concentrations actually increased on average. And that's because, again, not just heat can transform chromium-3 into chromium-6, but also drought conditions can too. So basically, these mycorrhizal fungi act as not only remediators and plant helpers, but they also create more stable conditions to prevent more hexavalent chromium from forming with existing chromium, which is really present in soils. It turns out that adding the decomposer fungus also was correlated with reductions in hexavalent chromium. So I don't think there's time to go through all the residential site past studies I've done, but I just want to go through all the details of capping, but I can share information about that through other forms. But I do just want to bring us up to the present. I shared about past studies we've done in LA area and identifying, methods that are suitable for these soils, this climate, and mixtures of contaminants in soils. So now we've been exploring, can these methods be applied to soil remediation of fire-impacted sites in the area? And actually, there's a lot of similarities between fire and industrially impacted soils. They're low in nutrients, typically, and organic matter. They're low in microbial biomass. They have poor soil structure, low water and nutrient retention, changes, like mostly reductions in plant and microbial community diversity. There's increased soil erosion and dust formation, right? There's these contaminants that are elevated, increased water runoff, and increased soil exposure and therefore temperatures. So we thought that, actually these methods we developed for industrially contaminated sites, whether residential or brownfields, could be very applicable to fire-impacted sites also. And we got together with some of our colleagues at Co-Renewal who have been doing long-term post-fire work in California, mostly in Northern California, and came up with this tech which builds on the typical wattle to prevent runoff and erosion by adding fungi into the wattles. And then combined with some of our soil remediation approaches and with colleague Maya Alson's work around biome logs, more to work on the long-term reduction of future fire risk. So if you want to check out, I don't have time to go through their work, but if you want to check out Co-Renewal's studies, they made this really cool Phoenix fungi web tool where you can put in information about your site and get recommendations on how to remediate the site through some of the methods they've looked at. I'm going to just pause and go through. Okay, wait. I want to just mention that combined approaches, so hotspot excavation and bioremediation, can be a really great idea. It's going to save a lot of money, right, compared to just digging up all the soil. It's going to be highly effective. And yeah, just you get the kind of the benefits of both approaches. As I said, I'm just going to move through my soil capping and stabilization content for another time, for a handout I can share. And yeah, I'll also skip over it. Some of you may have heard us talk about our bioremediation community trainings and workforce development programs we've done in high schools and in impacted communities living around factories or neighborhoods where the entire neighborhood has turned out to have contamination, which is a context very similar to with the fires, right? I'm happy to answer questions about that. We've been running these bioremediation programs connected to our pilot projects for the last 5 years or so. Yeah, and okay, I'm just going to really briefly mention some of our residential work because I think it is very relevant here. So this is one example we did in Santa Ana. We've done 2 cohorts now with 3 pilot sites in each. This was inspired after a UC Irvine researcher study identified a soil lead crisis in particularly disadvantaged areas of Santa Ana, and prompted this program where we paid community members impacted by the contamination to join us in this pilot project. We've also done similar projects in the city of industry around the Comeco factory. It was also a lead issue where we trained crews of landscaping companies to assist in an opt-in program for different types of remediation for lead-impacted families living in that neighborhood. There were 180 residences impacted, so it's a pretty big scale. Yeah, and we've done similar kind of residential bioremediation programs focused on sites where folks are growing food in their yards as well, with positive results, looking at compost, common crops, native plants, of course, mycorrhizal fungi, and we shared those findings in a free fact sheet available online. So. Yeah, the last item here is just a decision tree for post-fire soil cleanup. And we can walk through it briefly and also share this out after. This is something developed with our consortium. So again, first of all, did your home burn? Was fire debris removed? Has your soil been tested? If it hasn't been tested yet, you want to stop and get some soil testing, and that'll help you proceed through the decision tree and understand if you need remediation or not. Do you know where the contamination is? So with some of the free programs for soil testing, it involved a small number of samples, like maybe two or 3 composite samples where they're mixed together. That might make it harder to understand where the contamination is. If you're going to want to do a hotspot removal, a cheaper approach, or a combined approach, you're going to want to actually know where hotspots are on your site. So you might want to go back and do a bit of testing from individual locations on your site. So then, of course, you compare your contaminant, your soil test results with those residential health guidelines to understand if cleanup is needed or not. Consider those other considerations we talked about at the beginning, right? How urgent is your timeline? Do you have insurance? Who regularly is in contact with soil on the property, right? If there's a high risk context where there's young children or pregnant people, you might want to do just soil removal or, take more certain measures. And are you growing food on the property, right? That, again, is going to change how you proceed through your remediation process. So, and then just a reminder that regardless of what method you go with to do remediation, you'll need to verify and maintain soil test results, showing that cleanup is complete. You'll want to just maintain those exposure reduction practices in case, who knows, like dust or some other source brought some contaminant back onto the site. Save everything, all your test reports, your invoices, your lab results for insurance and for possible future sale. And retest if you're doing a stabilization or capping approach, or if there's construction or some other big disturbance on the site. And I'll just end here, but I do want to mention, before I end and open for questions, that CAER does have a no-cost bioremediation program that is currently accepting residents across both impacted communities. And so before I go into Q&A, I just want to make sure I tell you all about this. And I can follow up again with just a one-pager with all this info and the link to the intake form. So thank you to FireAid and to Greater Good. We are able to provide bioremediation at no cost to 50 residences impacted by fires. We will take care of everything, including detailed soil testing before, during, and after, design and implementation of bioremediation tailored to your site, monitoring and removal of the plants at the end. So the main things to know is that during the process, you will not have access to the areas being remediated. It will look like a native plant garden. It will be beautiful. We hope to begin remediation in April. And the period we are planning on carrying out the remediation, or the timeline, is about 1 year. This can be done at the same time as rebuilding. We can coordinate on that. And at the end, we will provide you with a professional report on your final soil test results and the cleanup status of your property. So in terms of eligibility, it doesn't matter if you have a total loss or a standing home, if it's a rental property or a personal residence. The main things are that we do need soil test results showing you have at least one elevated contaminant. We are not recommending bioremediation for properties with lead levels higher than 400 parts per million. For those, we'd recommend, unless it's like a combined approach with, removal of those hotspots. And that's not because it wouldn't work. It's just that we anticipate it would take too long based on our previous studies in the area with these same methods. We do need water access for the work. So we do have guidelines on how to get your water turned back on. So it just needs to be back on before we begin work by the end of April. You need to have that 1 year timeline for the completion of the remediation. Again, this can be alongside rebuilding. And we are having people complete an intake form just for the purposes of determining eligibility for the program. The window to apply is until April 1st, at which time we'll do a lottery. But we are prioritizing applicants who have young children or expecting newborns. That's because of they face the highest risk from exposures, and folks who are underinsured or just their insurance won't cover soil remediation, as well as people who are already living on site or will be moving back into their homes soonest. So I'll share the info. I'll drop the link in the chat on how to apply. Yeah, even if not everyone makes it into the no-cost program, we also offer low-cost bioremediation services as well, in the range of $7,000 to $18,000, depending on site factors, through our nonprofit. So I'm gonna just now thank you for your attention. And pause here for questions.
Thank you so much, Dr. Stevenson. This was incredible. Such a great body of work and some really great technical explanations that I think are giving our community some hope around soil recovery and some next steps. So congratulations on securing some of these grant funds, and thank you to the funders that are out there putting investments into soil remediation for our communities. It's incredible. I also want to personally thank from Eden Fire Residents United fire aid funds as well, because that has allowed us to continue our educational offerings such as this. So really grateful for all the funders that believe in this great work and are supporting our communities through the second year of recovery. And I know the soil recovery is going to be here, on the horizon for quite a while. And so definitely thrilled that you're looking for some of those grants and receiving those and bringing those to both fire affected communities. It's pretty incredible. So I've taken a lot of these amazing questions and I've sort of collated them. Christine, please feel free to add that question that you have to the chat, and I'll try and weave it in here. There's a lot of great questions. I do want to pause though and just say, can we give a round of applause for the AMF, like this AMF realization? Like, come on, little guys. Seriously, I know there was some folks also interested in is this AMF good for kids and plants? Is this good for our trees in our yards? Even if we didn't have contamination, is this a good thing to be, putting in our yards? So before we get into some of the other nitty gritty, just wanted to give a shout out to that piece, which I think was an exciting part of your work. So could you speak to that a little bit, please?
Yeah, yes, definitely. AMF are just part of healthy landscapes and healthy plants. So whether you're growing a veggie garden or not a veggie garden, any type of plants, yes, it would be great to have them. The thing to know about how to successfully get those awesome guys in your soil is that because they form through the root, they form those relationships through the roots of plants, they typically need to be applied at planting time. So you can either mix the inoculum, which comes as a powder, with your seeds when you sow, or put a little scoop in the hole when you're planting a tree or transplant. So it can be a little harder to get them in there after planting has already happened. But yes, if you're going to be planting stuff, please do. You can, not all, like with so many products, right? They're not all created equal. I don't work for or get paid by any of those companies, but there are some that I've just seen better results than others. And I can drop those in the chat. But you can buy them from the inoculum from garden stores and online and places like that.
Thank you so much. Is this safe for our kids and our pets? Like, is there anything that we should be worried about related to this, or is this just a piece of nature that's just underappreciated?
Oh yeah, AMF are totally safe. They are obligate symbiont. They need their plant partner to grow. Otherwise, they're just totally inert. They don't relate with humans. They really just want to connect with plants.
Super cool. I love it. It's making me like think about Avatar and all the amazing.
Literally was based on on mycorrhizal research. Yep.
Okay. I can imagine it. Okay, cool. Thank you. And I really appreciate too you making the connections between your work in brownfields and the fire zones and some of the similarities between the challenges that we're seeing in our soil recovery. And so these fire impacted areas, they're not considered brownfields, right? We're just making some comparisons that this is kind of the next stage of application. It sounds like there's like a growing body of research around application of these methodologies in the context of burned properties and particularly urban fire, wildland, urban interface fire type of zones. Is that correct?
Mm-hmm. Exactly. Yeah, it's kind of a newer area. So we're needing to draw on, a newer area of research, I guess. So,
Sure.
yeah, we're drawing on past studies done in the region on different types of contaminated soils, but with the same types of contaminants and similar properties.
Awesome. Thanks. And so do some plants really thrive under these kind of conditions? Because I think many of us have observed, some plants seem to have rebounded really strongly after the fires and are growing very robustly. So is that just that, they're well suited for this, for some of these conditions? And
Yeah. So definitely, I've seen that too. So for example, I've seen many of you might know Encilia californica. I think it's also called California bush sunflower. So I've seen it come back and really grow in a huge way in areas impacted by the fires. I've also seen a bunch of that telegraph weed and California buckwheat, which are plants we've tested that we found pull up metals like as are common after fires. So it was interesting to me to see them in, fire impacted areas as well as on brownfields. And yeah, I do think, right, like nature, we all need to be somewhere we have food and, we can live and get what we need. So when we see certain species coming in after some kind of disturbance, it's usually because they're adapted in some way to the conditions.
Incredible. And I know you've name dropped quite a few different plants and fungi. I tried to read your papers and they're pretty incredible. And there are also a bunch of words I do not know. So I know a lot of people here are interested in the names of plants and fungi that are best friends in these conditions. And so would it be possible for you to drop a link maybe to your PubMed, some of the articles where you talk about some of the plants that are very, very effective in this for the folks that really want to go down that rabbit hole?
Yeah, for sure.
Okay, cool. And we can always send it out later too, if that's if you don't have those readily available, that's totally fine as well.
Okay.
Okay, so you mentioned the importance of testing, right? So I think a lot of us just want an easy answer of like, what should I do, right? And I think many of us are still sort of accepting the answer that it's not really a one size fits all approach, and even on a single lot, we might utilize different methods, right? So some of the ways that we would even know how to navigate would be to test, right? And so does that mean that a lot of this really does need to be done in collaboration with an expert so that we can have that feedback? Or is some of this like if you don't if you're not looking for that sort of confirmation that contaminants are gone, that you could maybe embrace some, pretty reasonable approaches, but you'll never really know, right? So could you just speak for a moment on like the importance of testing and how that really helps cultivate like a unique approach that would be, appropriate in a specific context.
Yeah, testing is really important. I think of it like, going to the doctor, like getting your blood work done and things like that, right? So it's really just, otherwise we can look to symptoms, right? And try to kind of guess what is happening. But really testing is the way to really know what's going on. And there are still some free testing resources available. I can also share after. We have a soil testing handout that goes through local labs. You can send your samples also for pretty cheaply. I put together, for example, like Sunstar Labs. They will also pick up your samples for free if you're within 50 miles. And I put together, so for one sample for all the full mix of common post-fire contaminants, it was coming in around $380, just to give people a sense of what that costs. So I really recommend testing. I know it can be a lot, but there's resources for you, and it's really important. I think also, like many people who are dealing, potentially involved in a legal case, or insurance stuff or whatever, you're definitely just going to need those test results, and they will need to be, provided in a professional manner that meets requirements. Yeah.
Yeah, thank you so much. And I think you hit on a couple important things there. One I will clarify. So far, to our knowledge, insurance has not been covering any of the soil remediation. So we, are looking towards state, local, philanthropic finance, right, options. But the importance of testing, as you mentioned, like just because you're taking your vitamins doesn't mean you don't have regular health screenings, right? Or that you're not testing to sort of see where you're at. So should is a CAM17 test, like what are some of the things that you're testing for when you're doing that testing? Could you speak just briefly to that? Is it the CAM17, or do you have, like a list somewhere of what you typically test for in this type of recovery work?
Yeah, so I would recommend testing for CAM17, hexavalent chromium is separate, PAHs, VOCs. If that's all you can do, that would probably be a good mix. That's what I'd recommend. I mean, PFAS is probably present, but it's more expensive. I think it's like $350 per test for PFAS. So, yeah.
Thank you. And the testing also is the only way that we would really know where the hot spots are in our yard, right? So could you speak just a little bit to the composite testing? So a lot of the resources that are available to the community tend to be composite sampling methods, right? Where you go around and you place, multiple samples into the same bag, or in, maybe one from the front yard, one from the backyard, or something like that. And so, could you just speak a little bit to, let's say, maybe what your testing approach looks like compared to that composite sampling, or like what we should be mindful of just in the context of composite sampling?
Yeah, so composite samples give you more of an average, right? So it's helpful to just get a sense of which contaminants are maybe on site, but it's not going to give you accurate concentrations. It's going to give you more of an average, a lower number. So if you have really any contaminant showing up anywhere near the screening limit in a composite sample, it's something I would look into further. So that means I would do some discrete sampling. I would take just individual samples that I don't mix together from other parts of the property, And I would prioritize areas that there's more risk of exposure, right? So I would, if you're going to have a food garden, or, take a sample, at least a sample from the food garden area, take a sample from the topsoil of your yard where people might be hanging out. And yeah, in terms of number of samples, ideally take as many as you can, just because, again, it's a bit of money up front, but it could end up saving you money if it helps you identify areas that need treatment and areas that don't, right? So then you actually know, okay, I actually have this much lead in my yard, and, I have a hot spot of lead in the northeast corner, and I'm going to have that removed. So, yeah, that's kind of what I would.
Thank you. Super helpful. Very, very helpful. There's quite a bit of questions around like the affected areas, right? Like, and where should we prioritize? And so I think you were really touching on this, and that's really helpful around, prioritize areas where we're going to have the most exposure levels, right? So I really appreciated your breakdown of like a hazard times the exposure is your risk, right? So it sounds like we're prioritizing areas where there's going to be exposure, right? So questions that regularly come back to us are around like, if I'm going to be building my house on that footprint, right? Or I'm putting concrete down over, I'm making a concrete patio. Are those areas that we should really be prioritizing, or putting our, just resources into testing those areas and remediating? Or should we really be focused on the areas that are going to be used, recreationally or by pets, or gardening or whatnot?
Yeah, I would say so. So it's my understanding that an area that'll have like permanent cover, so it's going to be paved, it's going to be your driveway, it's going to be, literally the footprint of your home, on a concrete foundation or whatever. Those areas, to my knowledge, should be considered permanent cover, which should mean that shouldn't be really concerned about what contaminants may be underneath. There's some exceptions to that. There's always exceptions, right? But generally, yeah, I would focus on testing and remediating areas that are going to be like your yard, your garden, areas that are, where the soil could actually be, you could expose to the soil.
Gotcha. And so what about a crawl space? So folks, always want to know, there's this area under the house. It's kind of unclear how much smoke, soot, or ash got in that area. Should we be concerned about our crawl spaces, or again, places where we're going to be, regularly interacting with soil?
Yeah, so crawl spaces are tricky because they'd be tough to remediate also. I mean, I wouldn't be as concerned about it. Is there a way soil from a crawl space can get into the home? If there was, I would consider that, like get some filters or something on, whatever, if there is any type of access. Otherwise, you might be able to just, again, like cover the soil. Maybe that's a good spot to, cover the soil with like some mulch or gravel or something, and just completely remove any risk there.
Sure. Thank you. What about if our property is kind of already covered in plants? Like, should we worry about it if we've already got grass there, or we've got a beautiful, somebody mentioned they have a yard that's 100% covered by native plants. I would love to visit that yard, but do we just leave those cases alone and we're really focused on more soil exposed?
Yeah, so I mean, it's a good question. So it's hard for me to answer without knowing the soil test results, right?
Sure.
But generally, soil that's completely covered in plants are going to be holding that soil in place and reducing, contaminants as dust from blowing all around. So, yeah, I think I would still test the soil and see what's happening there, and then make a decision from there on, what to do with those plants.
And like you mentioned the beauty of some of these hyperaccumulators, right? Could it be that we just sort of leave the plants be, or do we really, like, let's say we do test the soil and we find that, yes, there's some higher levels of certain contaminants, and it's likely that those plants have, pulled some of that up into their root system. Is there anything wrong with just leaving those in place as like they're trapped in that, sort of living web, or is there a reason why, yes, you've got to pull those plants out, and then we've got to cross that road of like how to dispose of those? And I know we've got some questions in that area, but let's just start with the plants. Could we just leave it, or do we really need to, dispose of those?
Yeah, it depends. It depends on a lot of things. Sorry for the nuance. It's just, so again, it depends. Is the soil contaminated, and contaminated with what? But also, like, are they perennial plants, or are they annuals? So say the soil is contaminated and you do happen to be lucky and have, these beautiful hyperaccumulator plants growing on site. If they're annual and they take up those metals and then die and fall over,
Sure.
right? Yes, the cycle continues.
Yeah.
So yeah, it depends on a bunch of things. But I will say, typically your remediation contractor, whichever approach you choose, should be able to help you manage that plant waste. So the first step when we work on a site is actually we test the vegetation, and then we typically remove it and dispose of it properly.
Okay, great. And so on that note of disposal, right? Like, I'm not familiar in this moment around any sort of announcements to the community around, here's how we can compost plants from our yards at this time, or if we engage in these bioremediation efforts, like, how do we band together to have like an official hazardous waste kind of dump for plants? Is this something that we could imagine like getting together on a community-wide scale, or is this something that really we should do one by one with our soil remediation expert?
Yeah, I mean, I think I would love to see. I've always wanted to set up a community-wide program for that plant matter. But what you can do, I will say, Wallace Labs in LA does test plants for metals. It's a kind of cheaper way. I think it's like $80 a sample. It's a cheaper way to at least test some of those plants, and see how, maybe you can compare. You can find levels online for allowable, as like how the plant then needs to be disposed of based on those metal levels. What I've done on small residential sites in the past that you can do is, try to get that testing, see what the levels are like, and then just get some garbage bins without holes in them, and basically pack that plant matter into that. Get it, moist, put the lid on, put a skull and crossbones on it, like do not touch toxic stuff, and let it just break down again naturally over time. So that's a way to kind of concentrate it on kind of a backyard level. And then on a community level, right, you maybe get together, and that becomes, someone takes a trip to, to the hazardous waste landfill to get rid of that. So that might sound a little like involved, but we've done it before in the past. It's definitely doable on a small scale like that.
Great, thank you. So you mentioned some of the conditions that need to be present. So one was around water, right? The water being extremely important to keeping the soil moist and allowing for, being able to feed, right, some of those microbes and nutrients to the plants. So this is really an option that we need to pursue where homes or lots have access to water, right? And I think it speaks also to some of the maintenance folks should expect over time, right? This isn't just kind of like put it out and walk away. Can you speak a little bit to like the ongoing kind of maintenance or what that year-long process would involve? Is this like a once a week kind of thing, that's some sort of maintenance, or is this a twice a week thing? Like, just so folks kind of get a sense of like, let's say they spend the 5,000 year one, but then don't maintain it. That's kind of like, effort sort of lost, right? Like, what does that maintenance look like?
Yeah. So for the methods we work with, because again, there's so many different ways to bioremediate. For the methods we work with, and I didn't mention this, but I actually did test them with and without irrigation in my previous studies. And unfortunately, that's how we figured that bioremediation just happens faster and more effectively when you have water. No surprise, right? Even with drought adapted organisms. So it does work if you don't irrigate, but it just doesn't work really fast enough for people. So yeah, what the kind of life cycle of our bioremediation methods looks like is, again, so testing, comprehensive testing. So we typically take a minimum of like 30 samples per site. We test for the full range of contaminants that might be there to narrow them down. Then we make a site-specific bioremediation plan based on your needs and plans for the site and the contaminants and so on. Then we come and again test and probably remove existing vegetation. Someone asked in a recent presentation, but not my roses, right? So yeah, no, we're not removing trees or like established bushes or things like that. We're just removing like weeds and stuff that has come in since. And then we prepared the soil as if we were almost going to plant a garden. We put in our fungal inoculum and our plant seeds. And we do all of that in a very dense way, because with bioremediation, it's not the same as planting a garden. The remediation is only going to work where the soil is completely, in contact with these plants and fungi. And then we monitor. Yeah, we set up the irrigation or what have you, and we monitor probably on a weekly basis just for like growth, weeds. Is the inoculum? We test to make sure the inoculum that the plants are growing, so we can catch it if we need to like replant or reinoculate. And then we sample, so we test the plants, the fungi, and the soil every 3 months or so for contaminants and things like that. And then, that continues throughout the year-long period. And we either, depending on the site and the needs, we either go until we hit the remediation goals, which again can be different for everyone. Maybe we're trying to get lead to nothing, or maybe we're okay with the 80 parts per million. And then we harvest all that plant matter. We dispose of it properly off site. And you're left, and we do a final round of testing, write that all up in a report. You're left with like essentially really nice soil in your yard.
Awesome. And so you mentioned like this could be done at the same time, so parallel some of the rebuild activities. If you could speak a little bit more on that, but also speak on the just concerns about recontamination, right? So whether it's through the construction related activity or through wind or through one neighbor remediating their property, but the one next door not, there's just this constant sort of concern and worry, I think, with anxiety in our community around just the constant threat of contamination. And so could you speak a little bit to that? how big of a concern that really should be, or if this kind of approach can work in conjunction also with that sort of continual resuspension, let's say, of some particulate matter that may land on properties for whatever reason.
Yeah, I mean, recontamination is a real risk, and it was before, this context too. So, like, I'll give an example. When I was a young grad student doing my first study, I didn't wash the plants before I tested them for metal uptake, right? And I got the comment from an EPA, a helpful EPA, person who came to my poster and was like, well, if you didn't wash the plants, it's possible they just had they had lead on them on the outside and they didn't take up the lead. So yeah, that's something. And we have actually done little things since the fires, and yeah, since that helpful comment, where when we watch like a plant on a property, and this could be a site in our downtown LA, and it could be a site in a neighborhood where there's lots of rebuilding happening in Altadena. There tends to be, it's a hot, dry place. We have the Santa Ana winds, dust gets around if soil isn't covered and if there's disturbances. So it's a real consideration. There's also things you can do to mitigate for that. So if you're going through a remediation process, first of all, that's part of where retesting can be really helpful. Keep in mind that when it's like dust blowing off of a site, it's going to be pretty small concentrations of like lead or whatever. It still can add up over time. Probably don't want it. But yeah, retesting, give yourself peace of mind. Like, is this really an issue? Maybe it's not. Maybe it is. If it is, we've worked on remediation projects in the past where we actually had literal demolition and rebuilding happening on the site we were working on. And you can always utilize like row covers and different types of just like landscape fabric to cover your yard or whatever, and then prevent any type of airborne like deposition of contaminated dust or what have you. So that's one effort. You'd have to replace it because it should be catching the contaminated dust. There's also things like with some of those stabilization or capping approaches we didn't really talk about, but I mean, you have to maintain those anyways. So you typically will be replace it. I know wood chips aren't a good option for with fire concerns and things like that, but you're going to be needing to replace, whether it's compost or whatever you're adding to cover your soil, you're going to need to replace it anyways, because it does break down over time. And so, yeah, there's a lot of things you can do to mitigate for that, to test for it and see if it's really an issue.
Sure. And I think your comment about, putting into context the sort of the volume or the extent of that resuspension and recontamination or cross-contamination, right? Like, do you have a helpful sort of something to compare it to, like you had your shark comparisons? Like, because I think about this, right? Well, actually, I don't 100% know, but I would imagine that the cross-contamination that we're imagining is not going to be anywhere near the devastation caused by the fires, right? So, like, we're not, we shouldn't be concerned like all hope is lost, that every time the wind blows, we're recontaminated, right? It's like, is it sort of more of a manageable sort of contamination? Like as if we were living next to a freeway, and the freeway, I've lived near a freeway before, and there's some stuff that the freeway kicks up. And so there's some things that you can do to sort of, or reasonably sort of address the ongoing contamination you're going to be exposed to, over time. So can you just kind of help us wade through that one a bit?
Yeah, for sure. So, I guess one thing that was really interesting to me in studying environmental toxicology is learning how amazing adult bodies are at dealing with contaminants, like generally, right? So that's hopefully reassuring. Also, so again, it's like there's one layer I want to bring in is considering your level of risk, right? Again, if you have children, under 6, yeah, maybe more to think about there. That being said, there's so much you can do, right? Those practices that are so simple, but just getting into those healthy habits can really reduce your risk. Even we can share more resources about this too. I'm sure EFRU has resources about this, but like that, washing your hands, taking off your shoes before you come in, getting some good air filtration, cleaning your home regularly, these are all really healthy practices. Even if you're growing food crops, there's a lot you can do if you have concerns about contamination. Like lead is really heavy. It's dense. It's actually not super likely to be taken up into plants, which is why it's hard to remove with plants. There's been studies that have found that like washing your fruits and veggies can remove, I think it was like 80% of the lead, right? Which is mostly going to be just stuck on the outside. So I guess I'm just trying to frame, like, I totally understand how scary this can be and just hard it can be to even interpret, like, how safe am I? Am I safe? I guess I just want to share, there's so much you can do to reduce your exposures. There's so much you can do to, your yard, that's pretty straightforward and low cost. And then there's always added layers you can take, like with ongoing testing, to just give yourself peace of mind. I'll also say, and I don't in any way mean this to, I hope this is like helps put things into context, is like, yeah, like, LA, like, I think, LA is a polluted place, right? I developed asthma as an adult from living here. It is a polluted place, and folks who are going to be more vulnerable to that, it makes sense to take added precautions. But generally, yeah, there's so much you can do. There was already contamination. We're faced with, more contamination concerns after the fires. And yeah, there's so many things you can do at a pretty low cost to prevent that, even if there is a risk of like ongoing, like small amounts of contaminants getting around.
Thank you. That's super helpful. And I know we are already past time. Is it okay if I ask just a couple more questions and then we'll close out? Okay. Thank you so much. Let's see here. So, you had mentioned like, that the lead is pretty, heavy, right? Obviously it's a heavy metal. And we mentioned, some of these contaminants being in root systems. Like what about, fruits and so root vegetables, obviously, we'd probably want to be replacing that soil altogether, right? But like if we have like well-established fruit trees on our property and things like that, do you have any sense of like the extent to which, for example, tangerines or apples or avocados are pulling up some of these contaminants, and are those potentially hazardous to be eating, right? Because that would be that ingestion would be obviously a direct route to the body.
Yeah, so luckily fruit and nut trees are some of the generally considered some of the safest crops to grow when there might be contaminated soil. So that's because there's literally 3 different barriers that those contaminants would have to pass through to make it into the reproductive part, this precious, part of that plant. So that being said, that isn't going to matter if there's airborne contamination, like so ash from the fires or things like that. But luckily, airborne contamination can be washed off of those crops, right? And we did do a small amount of testing on different fruit, like citrus and stuff, on properties after the fires. And we basically sent them to the lab for metals testing. We washed half of them. We, didn't wash the others. And we only saw like lead and stuff of concern on the unwashed ones. So again, if you want peace of mind, these are all just general rules. There's so much complexity with all of this. If you want peace of mind for sure, you can actually send your fruits, your crops to Wallace Labs for testing and just get that peace of mind that it's safe.
Thank you. Well, this is very good news because last year we threw away all of our fruit, and in the past 2 days, I've consumed probably about 20 different tangerines from my backyard. So this is good news. And they're delicious. Okay, so you mentioned some really promising results related to various toxins, including hexavalent chromium. Are there any conditions where bioremediation would not be a good option? You mentioned there being sometimes a combo approach, would make sense on a property, but is there any place where bioremediation just wouldn't be something to consider?
Yeah, if lead was the only contaminant you had and it was like really high, like above 800, I wouldn't work with this type of bioremediation anyways. Again, it's really hard to remove from soils. We got more of it with those AMF, but it's just slow to remove from soils with plants. So, yeah.
Okay. So if there's really, really high levels of lead or maybe even some other contaminant, and is that something that people could reach out to you, with specific questions if they have results and want to know if bioremediation might be a good fit? Is that something you would be able to answer questions about?
Absolutely. Yeah, we definitely want people to get the help they need. So yeah, I would just tell you if I don't think it would be treatable with bioremediation. The other one I'll mention is it's not that it's not possible. It's just it's really in an experimental phase is asbestos. Sure. And that's because asbestos are mineral. It's like a formation of minerals. So it's sort of like metals. They can't be broken down. So I have seen some work looking at fungi and plants and stuff to treat asbestos, but it's still considered quite experimental.
Okay, thank you. And if some folks are interested in tackling some of this on their own, do you have any workshops or trainings or resources that you would recommend? I know there's quite a bit of interest in the fungi, the plants that you spoke about this evening. What could you say on the DIY front?
Yeah, I will say that we really need to set up some workshops. Yeah, I used to do those a lot and it's just been busy. But yeah, I guess one thing to think about is I really like to run workshops in a longer format. And that's because there is so much complexity and there's so much to share about this stuff. And we like to give people some hands-on experience. I guess that's another thing I'll put out there. We provide certain openings for people to help out with some of the work we're doing on some of our sites. And so that's a good way to learn by doing. But yeah, all of that will be shared through, CAER.earth on our website.
Thank you so much. Incredible. And just so other folks know on the call as well, this is something that EFRU, CAER, Resilient Palisades, we have been chasing down grants, trying to be able to bring back workforce development initiatives, more educational offerings, workshops, all of that. So we are trying and really, really, really appreciate the resources that have come through our organizations, and will continue to try to bring even more to the communities, because it's great to see this interest. So, okay, so we're going to get to the last. We always save the best for last, which is about cost, right? So, biting the bullet. You mentioned, let's say folks, had to pay out of pocket for this. You mentioned somewhere in the range of maybe $7,000 to $18,000. Do you have a price per square foot, or is this just more often it's typically in the $10,000 range in year one, and then if you sort of take it to the end with sort of replacing landscaping and bringing fire resilient plants onto the property, is that where you get to more of that 18,000-20,000? Like what's the in between, and what should people kind of expect in that price range?
Yeah, it's funny, Nicole. I'm like, I know that I calculated the price per square foot.
And you give it to me. Yes,
I'm like, what was it? I'm so sorry, everyone. It's end of day brain, and it's so hot today. I can possibly dig that up momentarily, but I will say, we base those prices on the average lot size in Altadena area. So, and there's I will say too, it really sometimes can be less, but we've been doing this stuff for so long. There's a lot of uncertainty with remediation, and so we build in for contingency. Like, did we need to replant because there was a heat wave and everything, or maybe we had to remove a hotspot, and or we had whatever it may be. There's actually PFAS, and every single contaminant we tested for shows up. So we try to give that range, and that should be the range for a standard sized site in across these regions.
Thank you. And that's what we've heard echoed from other folks as well. So I think these are definitely those, ballpark numbers that, that folks, that have a lot of experience in this area. That's what we're hearing. So I would trust that. And again, Danielle is available for consultation. Thank you so much for sharing some of the no cost or low cost options. There's hopefully many more of those coming to our community. Our soil consortium has multiple grant applications in right now and is hoping to submit more. I know there's just a lot of amazing work in this area that is getting started. We're very eager to hear about updates on the state's set aside of $2 million, right, for soil remediation of our communities, and Barger's office matching of $1 million for soil remediation. So we're eagerly awaiting what's going to come next of that. I know our community is eagerly awaiting the results of the recent EPA testing of properties, right? They came back and targeted about 100 lots. And they had announced this effort in our community to look at the extent to which contamination had persisted on some of those scraped lots, right? And so we're eagerly awaiting the findings from that. I think your comments, Dr. Stevenson, around, some of the limited knowledge that we have from some of the studies that are out there that have largely focused on lead, I think we, want to keep those in mind as well, that there's a host of things that when we think about truly restoring our communities, the things that we want to be mindful of, right? I don't think any of us want a bunch of things that we're not here before the fire just to persist. It's kind of like this lasting trauma for our communities. So EFRU and our partners on this call will continue to advocate and try and bring more resources. Thanks, Dr. Stevenson, for an amazing presentation.
My pleasure. Thanks for having me. Take care, everybody.